Hello grade 12s. Term 1, you are going to start with number patterns. And in this topic, generally, you've got two things that you're going to deal with. Number 1, you are going to deal with what are called arithmetic patterns. And number 2, you are going to deal with what are called geometric patterns. So basically, that's what you'll be doing. Now, we are going to divide into subsections. For arithmetic, you are going to have what is called a linear. Then you are going to have what is called a quadratic. Then you are going to a third one, which you are going to just call neither, because it's not going to be this, it's not going to be that. So it's going to be neither linear nor quadratic. Okay, so just a quick summary before we start. When you're doing with linear, there's this thing which is called constant difference. We are going to show using examples. You are going to find your common difference on D1 or on the first trial. For quadratic, you won't find your common difference on D1 or on the first trial. You find it on D2 or second trial. Now, if you don't find your common difference on D1 and D2, and you have to go beyond D2, you're not allowed to go beyond D2. You just write neither. That's where this third one comes in. So basically, you are just doing these two, and this is a bonus. Okay, so let's begin. Under arithmetic, let's start with linear. Remember, linear, that's where we said you find your common difference on the first difference. And we said quadratic, you find your common difference on the second difference. Okay, this one was on D1, this one was on D2. So let's write examples for linear. 1, 2, 3, 4. Let me write another pattern. 2, 4, 6, 8, and 3, 6, 9, 12. All right. So I'll first explain the concept, then I'll show you how we usually do it. So when you're finding the common difference, let us take the first pattern there. That's what we are going to use. 1, 2, 3, 4. When you are looking for the common difference, take note of this. Whenever you're dealing with this topic, finding the common difference first is always a good idea. So the concept is, you say term 2 minus term 1. We call these terms term 1, term 2, term 3, term 4. Term 1, term 2, term 3, term 4. Term 1, term 2, term 3, term 4. We call them terms. Anyways, so term 2 minus term 1. We say 2 minus 1. This is the concept. Okay, you get a 1. Then you say this minus that. Term 3 minus term 2. Okay, this is 3 minus 2. 3 minus 2, you get a 1. Then term 4, or the fourth term, minus the third term. This is 4 minus 3, you get a 1. So because all these numbers are the same, that's the difference, is the difference between this and this and this, this and this, this and this. So because all these differences are the same, they are called a common difference. So you write D is equals to 1. You have managed to find the common difference. So this is the concept. Always keep in mind that you say the second term minus the first term. Now, what we actually do to make things faster for us, you remember our sequence is 1, 2, 3, 4. What we actually do to make things faster for us is you just draw lines like this, joining two numbers. Then you say 2 minus 1, you get a 1. 3 minus 2, you get a 1. 4 minus 3, you get a 1. We always do it like this in a diagram. It's faster, and it doesn't take much space like that. The next one was 2, 4, 6, 8. 2, 4, 6, 8. So As we said, you draw two lines joining, two lines joining, two lines joining. Okay, so how do we find the common difference here? 4 minus 2, get a 2. 6 minus 4, you join here, get a 2. 8 minus 6, you join here, get a 2. So our D, or common difference, is 2. I want you to take note of this. It will be wrong if you say 2 minus 4, because 2 minus 4 is going to give you a minus 2. Minus 2 and 2 are not the same. Okay, if someone tells you to go and put the air condition in your room to 30 degrees Celsius and you go and put it on minus 30 degrees Celsius, I don't think you agree that things are going to be fine or things are going to be the same. So because of the negative sign, the difference is 60 degrees Celsius in error. So just watch out, because some students might have a problem and forget, then they say 4 minus 6. That's very dangerous. So always remember, you say term 2 minus term 1. Okay, so let's finish this up. The last example on linear, we said 3, 6, 9, 12. So you join this, 6 minus 3, we get a 3. 9 minus 6, we get a 3. 12 minus 9, we get a 3. So our common difference here is a 3, and we just call this the first difference, or D1. Okay, the first difference, or D1. Okay, we're done with this. We wanted to deal with quadratic as the next thing. Now, remember what we said under arithmetic. We said we've got linear and we've got quadratic. And on linear, you get your common difference on D1. But on quadratic, you won't find your common difference on D1. You actually get it on D2. So you shall see as we are doing examples. So let me give you examples, then we continue. Okay, done. So we've got these examples. They are supposed to be quadratic number patterns. So let's see. As I've said before, finding the common difference, D, is always a good place to start when you're dealing with patterns and sequences. So the first one is 5, 19, 41, 71. So how do you find the common difference? The same thing which we're doing in linear. You draw these two lines and you say 19 minus 5, that's a 14. And 41 minus 19, that's a 22. 71 minus 41 is 0, that's a 30. So as you can see, in the first difference here, we did not find common D. These things are not common. They are not the same. So you continue. This becomes a new pattern. So you continue. 22 minus 14, you get an 8. 30 minus 22, you get an 8. So you see, that's what I was trying to say, that on D2, that's where you find your common difference when it's a quadratic pattern. So D2 is your common difference. It's 8. That's on the quadratic. Let's quickly do the second example. 4, 7, 12, 19. Okay, let's find the common difference here. 7 minus 3. Oh, sorry, 7 minus 4 is actually a 3. 12 minus 7, that's a 5. 19 minus 12, that's a 7. This is our first difference. So they are not the same, so it's not a linear. Let's go to the second one. 5 minus 3 is a 2. 7 minus 5, that's also a 2. So when your second difference is the same, this is your common difference. So we are agreeing that this number pattern is a quadratic. Okay, now this one 6, 13, 22, 33. Let's finish. 6, 13, 22, 33. So they say that this is a quadratic pattern. Let's see, let's find the common difference. So as we said, you join these two and you say term 2 minus term 1. So it's 13 minus 6, we get a 7. Term 3 minus term 2, 22 minus 13, that's a 9. And 33 minus 22, that's 11. Okay, so there's our D1 is not the same. So let's continue. 9 minus 7, you get a 2. 11 minus 9, you get a 2. So our second difference, D2, is the common difference. It's 2. So this is a quadratic pattern. But usually you don't need to write D2. You just write D is equals to 2. However, I'm mentioning D1 and D2 because they are going to mention those things in your questions. So D1 is linear, D2 is quad. Okay, so if you don't get a common D on D2 and you are supposed to do a D3, don't do the D3. You just write neither. Always remember that. So that's the third case. And this is a good thing because you won't do all the calculations which you are going to be doing in linear and quadratic. Examples: 1, 3, 9, 20, 3, 9, 16, 21, and 4, 6, 11, 30. So let us start with 1, 3, 9, 20. So let us check what we get in the first difference. 3 minus 1, we get a 2. 9 minus 3, we get a 6. 20 minus 9, we get 11. So we see that this is not a linear because they are not the same. So we continue. And 6 minus 2, we are getting a 4. 11 minus 6, we are getting a 5. So the second difference is not the same, so it's not a quadratic. So you don't calculate the third one. Then you say it's neither. You can just leave it like that. But what are we saying when you're saying neither? We are saying it's neither linear nor quadratic. That's what we mean. It's neither linear nor quadratic. It's not a linear. It's not a quadratic. Okay, so this was the first example. Let's do the second one. 3, 9, 16, 21. Okay, so let's check the first difference. 9 minus 3 is a 6. 16 minus 9, that's a 7. 21 minus 16, that's a 5. So this is not a linear because the first difference is not the same throughout. So you continue. 7 minus 6, you get a 1. 5 minus 7 is a minus 2. So the second difference is not the same as well. So you write it's neither linear nor quadratic. Okay, so let us finish up. The third one, 4, 6, 11, 30. 4, 6, 11, 30. So 6 minus 4, you get a 2. 11 minus 6, get a 5. 30 minus 11, we get a 19. So this is not a linear because the D1 is not the same. So let's do the second line. 5 minus 2, we get a 3. 19 minus 5, that's a 14. So this is not the same throughout, so it's not a quadratic as well. So you just write it's neither. All right, the first thing which you have to remember, always find D, the common difference. It's always a good thing to find that when you are given number patterns. The second thing, always say term 2 minus term 1. Be very careful. Some people can say term 1 minus term 2. No, be very careful. We don't say that. Always say term 2 minus term 1, term 3 minus term 2, and so on. What am I saying? 3, 4, 6, 7. Always say 4 minus 3. Okay? 6 minus 4. All right? And 7 minus 6. Always do that. This minus that, this minus that, this. Okay, lastly, when your common difference is on D1, just remember that's linear. And when you don't find it there, you still continue to do again. When you find it on D2, it's now quadratic. And if you don't find it on D2 and you have to do the third one, you don't write the third one. You just write neither. This was just a video showing you the concepts and how we do the calculations and how you present your answers, how you do your calculations.